Standard 8 Maths Expansion Formulae Part 3. Students, we have learnt about the expansion formula x plus a into x plus b in the last lesson, and we have solved the exercise 5.1. I had solved two sums and I had told to solve the remaining sums for homework. I hope you have done that. If not, watch the video again and solve exercise 5.1. Now we are going to go to the next expansion formula. Okay, now that expansion formula is a plus b the whole cube. When you are saying this, you have to say it as a plus b the whole cube. Okay, now what does this mean? A plus b the whole cube. This is a plus b multiplied by a plus b multiplied by a plus b. So this is 3 times we are multiplying a plus b. Now we know when we multiply a plus b 2 times, what we are going to get. This is a plus b whole square, a plus b into a plus b. That will be a square plus 2ab plus b square. So instead of these two, we can directly write this. Now this we have to multiply with a plus b. I hope you understand why I got this. When I write a plus b whole square, this is the full form. Here there are two. This is a plus b into a plus b. So a plus b whole square. I wrote, instead of these two a plus b, I have written this. And this third a plus b is as it is. So now I have to multiply this whole equation with this, or this with this, whatever. So I can write it as like this: a plus b multiplied by a square plus 2ab plus b square. I have just interchanged the, that is for my convenience. I have done that so that multiplication will be easy for me. Now we have to multiply this a. This a we will first multiply with whole a square plus 2ab plus b square. Then we'll multiply this b plus b. Again we'll multiply it with a square plus 2ab plus b square. Now what we are going to get? I'll write the whole equation so that you will understand. So this will be this a multiplied by a square. Then plus sign this a multiplied by 2ab. Again plus sign. Then this a multiplied by b square. This I got here. Okay. Instead of this, a multiplied by a square plus a multiplied by 2ab. This a we have to multiply to each of these three terms. This is first term, second term and third term. So a is first multiplied with a square, then a is multiplied with 2ab, then a is multiplied with b square. Similarly, we have to do with this b. So now plus sign b multiplied by a square plus b multiplied by 2ab. I'll go in the next line, plus b multiplied by b square. I hope you understood this, how I have opened the bracket and how I have multiplied. A is multiplied with the three terms, b is multiplied with the three terms. Now let us write the product, what we get after multiplication. So a into a square. This is 1a and this is a square. So this will be a cube. A into a square. This is 1a raised to 1. So by the laws of indices, a raised to m into a raised to n, a raised to m plus n. So when we multiply the bases, we add the index. This will be, now here plus a into 2ab. Now here there is 1a, here there is 1a. So there are how many total? 2 a's. So the number we are multiplying, there is no number. This is 1. So the number will remain as 2. But a, here there is 1a, here there is 1a. So it will be a square and b is as it is. A into 2a will give you 2a square and then b. Now plus, here there is nothing common. This is a, this is b. So we have to write them separate. ab square. It will remain as ab square. Then plus. Now this is what? b into a square. Now see here, it is a into b square. Here it is b into a square. So here it will be b a square plus Now 2ab into b. So this will be plus 2 will remain as it is. A also there is 1, so it will remain as it. There are two b's over here. So there will be 2b square. And then this plus b cube. Why? B is 1 and here b 2. So this will be b cube. There are three b's over here. Now let us see what are the like terms. Like terms means what? The variables should be same and the index of the variable should also be same. Variable means a or b in this case. And index of the variable is this top what we have written, index. That also should be same. Now let us see which are the like terms. This is a square. Is there any other? Sorry, this is a cube. Is there any other a cube? No. So there is no like term for this. Now this, we will not see the number. Only we have to see the variable and the power. So don't look at these numbers. A square b. Do we have any a square b? Here, see here. This is a square b. Even if it is written this way, b a square, it is same as a square b. So these two are like terms. 2a square b and this is 1a square b. No? There is no other number here, so it is 1a square b. We can write it as 1a square b. These are like terms. Then any other like term now here? ab square. a1 b2. But here also we have, see, a1 b2. So these are also like terms. So we will underline this. Now here there is ab square. So it is 1ab square. Now let us add these like terms. Like terms. Now while adding we have to add the numbers. While looking for like terms we look at the variable and their index. But for addition purpose now we will add the numbers which are there or the constants which are there with the variables. So this is a cube will remain as a cube. There is no change over here. This will remain as a cube. Now plus 2a square b and 1a square b. So it will be 3a square b. 2 and this is 1. So 3. And a square b will remain as a square b. Plus. Now let us take this one. 2ab square and 1ab square. So there also it will be 3ab square and plus b cube. So the formula for a plus b whole cube is, you have to remember this formula as I have told you. All these formulae you have to remember, because in exam if you get a sum or based on this formulae, you will not be doing whole of this and then doing the sum. So for solving the sum you should remember this. So what is the formula for a plus b whole cube? It is a cube plus 3a square b plus 3ab square plus b cube. So 3 is 2 times. One time it is a square b first term square second term. Next time it is first term second term square. This is first term. Now what is first term and second term here? First term. A is first term. First means pehla, first term. Second term, second. So this is first term cube plus 3 into first term square second term plus 3 into first term into second term square plus second term cube. So this formula you have to remember. So based on this we will solve the exercise now. 5.2 few sums we will solve based on this formula, this expansion formula. So you remember this expansion formula. All these expansion formulas you better write it on a piece of paper and stick it somewhere so that it will be in front of your eyes every time and you will learn it properly. Now see, first sum we'll do of 5.2, that is 5.2 sum number 1. It is k plus 4 whole cube. Now each time you do the sum you have to write the formula, remember. Why is that? First of all, which formula to be used you have to find out and write, and secondly your sum will not go wrong. So now what formula we are going to use? A plus b whole cube, that is equal to a cube plus 3a square b plus 3ab square plus b cube. So you should remember this formula. Now what is a here? K is equal to a, and what is b? 4 is equal to b, isn't it? In this equation we will put this. So what is in place of a? k. What is in place of b? 4. So here we will substitute now. In place of a we will write k, and in place of b we will write 4. So what should I get here? First term, what will I get here? A cube. So I'll get k cube plus. Now numbers will remain the same, 3. There is no substitute for 3. So 3 will remain as it is. Now a square. What is a? K. So it will be k square. And b is what? 4 multiplied by 4. So here we have not put the multiplication sign. Why? Because these two are alphabets side by side. But here now there is an alphabet, there is a number. So we have to put the multiplication sign. Even if you put the multiplication sign over here, it is not wrong. You can write 3 multiplied by a square multiplied by b. Okay. But here we don't put it because it is easier for us to remember the formula when we don't put the multiplication signs. But here when you are solving the sum, you have to put the sign. Then plus 3. Now what is over here? 1 only a. So 3k multiplied by b square. b is 4. 4 square plus b. What is b? 4. 4 cube. Now let us solve this. So this will remain as it is. K cube. Now numbers we have to multiply. This 4 and 3. Wherever there are numbers, we have to multiply them. 4 3s are 12. And this k square will remain as it is because it is not a number, it is alphabet with the index, so that will remain the same. Plus, now here there is 3 and this is 4 square. Now what is 4 square? 4 into 4, that is 16. So this will be 16 multiplied by 3. I'll just write here, this will be 16. Why? Because it is 4 square. So this will be 3 into 16, that will be 48, and k will remain as it is. There is only one k over here. Okay. Now this is k cube. Sorry, 4 cube. What is 4 cube? 4 into 4 into 4. 4 cube. 4 into 4 is 16, and 16 into 4 will be 64. So the answer for k plus 4 whole cube is k cube plus 12k square plus 48k plus 64. So if you don't understand, see the video again and again and try to understand how we have done the sum. Now we will do the next. We will do the sum number 6 because this I did the sum number 1. Then sum number 2 also I think I will do it later. 3 sum number is easy, and then I'll do sum number 5 also. So one sum I am doing. So now this sum number 6 is, it is x plus 1 upon x whole cube. This is the sum, x plus 1 upon x whole cube. So first, which formula we are going to use? We are going to use the formula of a plus b whole cube. Write down, that will be a cube plus 3a square b plus 3ab square plus b cube. Now what is in place of a over here? X. And what is in place of b over here? 1 upon x. So we will substitute. In place of a we will write x, and in place of b we will write 1 upon x. So first here, what is a cube? So it will be x cube plus 3 into a square. Now what is a? You can put the multiplication, x square. Why? Because a is x. Multiplied by b. What is b? 1 upon x. Then next, plus 3 multiplied by x, b square. Now 1 upon x. Whenever you have a term like this, put a whole square. As I told you earlier also, I think when we did the indices lesson, that whenever you have a fraction or whenever you have a number along with the constant, you will put the bracket and put the square. And this will be, now b is what? 1 upon x. So here also we will put it as cube. I hope you have followed how I have got this. X cube. Why? Because it is a cube plus 3 multiplied by x square into b, that is 1 upon x plus 3 multiplied by x multiplied by 1 upon x square plus 1 upon x cube. Now we will open it and find out the answer. So this x cube will remain as x cube. Now 3 into x square multiplied by 1 upon x. Now here there are 2x, isn't it? It is like this. 3 into x. X square means multiplied by 1 upon x. So I can cancel this 1x with 1x over here. I hope you understand what I have done over here. This 3 multiplied by x square. So x square is x into x. And this is multiplied by 1 upon x. So this x is in the denominator. So when there is 1 x in the numerator and denominator, we can do the cancellation. So 1 x gets cancelled over here. This x is left. Then plus 3 into x. Now here there is 1 upon x into 1 upon x. So 1 upon x into 1 upon x. Now this x and this x I can cancel. 1x down and 1x up. So I cancel. 1 upon x is remaining. Plus 1 upon x. Now open the bracket. So it is 1 cube upon x cube. But 1 cube is 1. So I don't have to write it. So it will be 1 upon x cube. Now again I will see what we have cancelled and what is remaining over here. So here we get x cube plus 3. Now what is left here? 3x, because this x is cancelled with this x. So there is no x in the denominator now. Denominator x is cancelled with 1x in the numerator. So I got only 3x. Now here what happened? Here there is 3. Correct. But this x is cancelled with this. There is 1x remaining in the denominator, that is down. So I will get 3 upon x. Okay. This 3 is in the numerator, x is in the denominator. That's why I get 3 upon x. This x is cancelled with this. 1x has been cancelled. So there is no x up and there is 1x only in the denominator. So I get 3 upon x and plus 1 upon x cube. So I got the answer for x plus 1 upon x whole cube as x cube plus 3x plus 3 upon x plus 1 upon x cube. I hope you have followed this sum. Now one more sum we will take. Two more sums actually. We'll do two more sums. One sum is like this. See, sum number 4, or we can take sum number 5 also. Sum number 5 and sum number 4 are similar. So we'll take sum number 5. 101 whole cube. Now this sum we have to do. Now we had 101 whole cube means what? 101 into 101 into 101. But I don't have to do actual multiplication. I have to solve it using the formula. So for using the formula, what is the formula now? When it is cube, it will be a plus 1. Now what will be a and what will be b over here? I have to use this formula, a plus b whole cube. Correct? That is a cube plus 3a square b plus 3ab square plus b cube. But what should be the a and b over here? Now how can I write this 101 in this form, a plus b form? So that will be 100 plus 1 whole cube. See, 101 whole cube. So that is 100 plus 1 whole cube. Same, na? I can write it. 101 is 100 plus 1. So 101 whole cube is 100 plus 1 whole cube. Then I can write down this formula. Now what will be a over here? It will be 100. And what will be b over here? That will be 1. Now let me substitute in this formula. First a cube means 100 cube plus 3 into 100 square into 1 plus 3 into 100 into 1 square plus 1 cube. See if you can follow what I have written over here. A cube, what is a? 100. So 100 cube plus 3 into a square. A is 100. So 100 square into b, that is 1, plus 3 into a, that is 100, into b square, that is 1 square, plus 1 cube. Now 100 cube, how will you write? Will you multiply this? Will you multiply 100 3 times? No. What we will do? See, now 100 there are 2 zeros. So we are going to multiply 100 how many times? 3 times. So we will have total how many zeros? Here there are already 2 zeros. So one more time and 2 more times. So total we will have 6 zeros when we multiply 100 into 100 into 100. Total zeros will be how much? These are 2. Then see, now 100 into, when I say 100 cube, that means 100 into 100 into 100, right? So 1, 2, 3, 4, 5, 6 zeros. Okay. Now plus 3 into, now 100 square, that will be 4 zeros into 1, plus 3 into 100 into 1 square is 1, plus 1 cube is 1. Now let us completely add, write this properly. 1, 2, 3, 4, 5, 6. Count the zeros when you are writing. 3 into, how many? This will be 1, 2, 3, 4 zeros. So 1, 2, 3, 4 into 1, it will be same. Plus 3 into 100, that is 300, and plus 1. So first term, then this is the second term, this is the third term and fourth term. See here, when we open this bracket, we are having how many terms? 1, 2, 3, 4. Here also we should have 4 terms, and then we will be doing the addition. So while doing the addition, you can write one below the other, or if you can do the addition like that only, you can do. So it will be what? Here it will be 1, then that will be here, second will be 0, third will be 3, fourth will be 0, fifth will be 3, 1, 2, 3, 4, 5, then sixth will be 0, and seventh will be 1. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this will be our answer for 101 whole cube. You can do the addition in this way also. 3, 4, 5, 6 plus 1, 2, 3, 4. Right from the right side. So your zeros will not go wrong. So 1, 0, 3, 0, 3, 0, 1. Okay. Similarly, you have to do the fourth sum also. So we have done the sum number 1. We have done sum number 6. We have done sum number 5. So I think you will be able to do the remaining sums. Try it out, and if you cannot, we will discuss